See my screen?
Yes, I can.
Okay, cool. Actually, I want us to actually do the summary of what we just covered now. This is actually population. Let me just say ODE application. ODE's applications. Okay, with the ODE's application, we covered what you call this population growth. And I mentioned that when k is less than 0, we have what we call is a decay, and then when k is greater than 0, we have what we call growth. And then the equation which is governing population growth is given by dA over dt. Let me write like a decent person. Is dA over dt, which is equals to Ka. As I mentioned previously, that this is application of what? Application of separation of variables. Separation of variables. And then you need two conditions. You need the initial one, you need the initial condition and the boundary condition to actually solve this problem. Since this is an application of separation of variable, it means that to solve this, you're going to have your a's on one side and your k on one side. How? You're going to have dA over dt, which is equals to kt, and then if you separate this, you're going to, it's ka. If you separate this, you're going to end up with dA over a, which is equals to k dt, and then you integrate both sides, and then you're going to end up with ln of what? Ln of a, which is equals to kt plus c. And then this is the equation that we will be used to calculate for the value of c and the value of k based on what? Based on the conditions that you will be given. So they will require you to get the equation of a of t. They will require you to calculate for time, or they will require you to calculate for the amount of population when you are given time. Let's say maybe you're given time as 1.5. A of 1.5 will be equal to what? You're going to use this equation here to get the value of 1.5. Are we clear on that one?
Yes. Can you please go to the previous page?
This one.
Okay, thanks.
And then number 2, we have covered the other one, which is what do you call this? We have covered Newton's law of cooling. Newton's law of cooling. With the Newton's law of cooling, as I have already explained, that this one, it has to do with the temperature, and then with the population growth, it has to do with the population of a certain environment. You understand? So with the Newton's law of cooling, it has to do with temperature. Let me just write this. NB, which is temperature. So as you have already seen, I have mentioned that when you talk about Newton's law of cooling, it is defined as the rate at which a body is cooling is directly proportional to the difference between the temperature of the body and the temperature of the surrounding. And mathematically, I mentioned that we represent this as dt over small t. This small t dt, it means what is a rate of change, k into t minus tm. The tm, as I have already mentioned, that is the temperature of the environment. The temperature of the environment. And then I said example, temperature of a room, temperature of the environment, or temperature of the surrounding, or temperature of the atmosphere. And then e.g. I said a room. And then the k, I mentioned that k is the proportion is the constant proportion, So you're still gonna do the same thing with what we were doing previously, separating the variables on your left and on your right. So to solve this problem, you also need two conditions. You're gonna need the initial one and the boundary one. So what you're gonna do when you're given problem like this, they will give you a long paragraph, so just to confuse you. Hey, this is what happened, the thermometer did that and that. Hey, Jesus Christ, the Modimu. Don't just focus on what? On the two conditions that they have given you on the question. That's just focused on the conditions which they have given you, and then after getting those conditions, you will be required to calculate for you'll be required to calculate for I need the other one which we're doing. Okay, it's fine. You'll be required to calculate for T of t, which is the equation which will be governing that equation that will be given, and then you'll be required to calculate the time. What is the time? They will give you the temperature, and then they ask you what is the time, and then you'll also be required to calculate what? You'll be required to calculate. They also give you T of 5, and they want you to give us or to give them the temperature when time is 5. Let's say at 5 minutes, what is the temperature? So you're gonna say T of 5 is equals to blah 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 blah. Let's say maybe your equation is T of what? T of t is equals to 20 e to the exponent 5t plus 20, and they say when time is equals to 5 minutes, what is the temperature? So you're gonna say T of what? T of 5 is equals to 20 e 5 multiplied by 5 plus 20, and then you get your answer. What will be your answer? Quickly, guys. This is not supposed to take more than 2 minutes.
It's 1.44 to the power multiplied by 10 to the power of 12.
It's 1, what? 44.
44.
Multiplied by 10 to the power
of 12.
negative 12.
No, 12. Positive 12.
So this will be your temperature in degrees Celsius. You understand? So as I have already said, the equation that is governing is dt over dt, which is equals to k into t minus tm. I mentioned all this, the temperature of the surrounding. So to solve this separation of variable, you're gonna have dt over t minus tm, which is equals to k into what? Into k. Yeah, dt. It's a sign that our class should end. Dt, and then you integrate both sides. If you integrate both sides, you're gonna end up with ln of what? T minus tm, which is equals to kt plus c. Tm will be given. This will be given. Tm will be given because it's the temperature of the environment. Temperature of the environment or temperature of the surrounding. You'll be given. So the two conditions will help you to get the value of what? The value of c and the value of what? And the value of k. And then you will be good to go. So tomorrow you're gonna be busy with what is remaining. Any questions? Any questions? Okay, then it means everyone is fine. There are no questions. So we're gonna stop here for today.